This lesson is going to be about waves and energy, and the learning target is to be able to describe how the properties of a wave affects its energy. So we can get an idea of this phenomenon by looking at a couple of real-world examples here. We have two different types of waves. On the left-hand side, we have a pretty big wave crashing down onto the surface of the water. And on the right-hand side, we have some gentle, soft waves on a sunset. If you look at these two pictures, you can tell which one has more energy. These waves are crashing down onto the surface. They have quite a bit of energy because they're so high off the surface of the water. These waves over here are pretty gentle. They're not really holding a ton of energy. And if we were going to draw the waves, what they look like from like a side view angle here of what the waveform looks like, these ones would probably look something like this. And these ones would be much larger. And if we look at the difference between these two waves, I'm not a great drawer. They might have different frequencies, but I don't think it's too much different here. Where a lot of the difference between these comes from is their amplitude. Remember, the amplitude is the disturbance of these molecules that the wave is traveling to. So this right here would be our amplitude of our bigger wave, and our amplitude for our smaller, nice little gentle wave would be right here. And so we can see that in these ones, the amplitude's much higher. This water is way higher off of the surface than these waves are. And one thing that we're going to talk about in here is that the energy of a wave is directly related to the amplitude of that wave. The more amplitude the wave has, the more energy it holds. And if we remember back to how a wave is formed through a vibration. This guy here is shaking this rope up and down. Right? Now, if he shakes it higher and lower, obviously not going to go through the ground, our waves are going to be much bigger. Right? He's putting a lot more energy into it when he shakes it higher and lower, and our wave responds by having a greater amplitude. So the energy being put in is carried by the wave, and it results in that higher amplitude. So we can remember that if we have more amplitude, we have more energy coming through our wave. And it all comes from the source. And so the big idea is that the energy transferred by a wave depends on its amplitude. We can see that from the difference between the rest position here, how high that little green dot has to move, as opposed to this one here, where we have a lot more amplitude and thus more energy. So if I was going to say which one has more energy, the bottom one has much more energy than the top one. But if we change the number of waves per second, if you think about if you were, somebody right here holding on to the other end of this rope, how much energy are you going to get by these waves? If I have waves that look like this, right, versus a wave that looks like this, now they have the same amount of energy per wave because they have the same amplitude. I kept the amplitude the same on these two examples, right? So each wave holds the same amount of energy. But in this wave, we have many more waves hitting our target as opposed to this longer wavelength with a lower frequency. And so if we change the frequency, remember, which is the amount of waves that goes past a certain point per second, if we increase that frequency, the total amount of energy that's going to hit our target per second is going to increase because there's more waves. If we decrease our frequency and have really long wavelengths, our energy, the total energy that's going to go, is going to go down. It doesn't change how much each wave holds, but just the total amount of energy that's going to be transferred by our waves in a certain amount of time, which is very important. And so to wrap this up, the energy of the waves is directly related to the amplitude and the frequency. The difference between these is the amplitude affects the energy of each wave. Higher amplitude means we have more energy, and the frequency affects the energy transferred by the wave per second. Because if we have a greater frequency, there's going to be more waves per second than if I have a lower frequency. Hopefully that wave makes sense, but I hope that this helps you understand how the properties of a wave affects the energy of those waves.